Hi everyone, namaskara. Welcome to Tech Girl Kannada YouTube channel.
Now we have the new concept called the pigeonhole principle. If m pigeons occupy n pigeonholes, if m is greater than n, then there is a possibility that ಒಂದೇ ಹೋಲ್ನಲ್ಲಿ more than one pigeon ಇದೆ ಅಂತ. 2 or more occupies the same pigeonhole, or else if m pigeons occupy n pigeonholes, then at least one pigeonhole must contain p plus 1 or more pigeons, where we have it as m pigeons occupy n pigeonholes. So we have p is equals to m minus 1 by n. So the formula is given by where p is equals to m minus 1 by n. Now let us consider ABC is an equilateral triangle where 1 centimeter side length. If we select 5 points inside the triangle, prove that at least 2 of these points are such that the distance between them is less than 1/2 centimeter. We can form 4 equilateral triangles of length 1/2 centimeter inside the big triangle. So we have drawn 4 triangles because they have given at least 2 of these points such that we'll be having less than 1/2 centimeter distance between them. So we need to place 5 points in 4 triangles. At least one triangle contains 2 points in it. So how we are proving? You can see that in this diagram ABC, and we have created another triangle inside, that is DEF, inside which we have 1/2 centimeter distance of each triangle. But only in AEF triangle there are 2 points where the distance will be less than 1/2 centimeter. Prove that in any set of 29 persons, at least 5 persons have been born on the same day of the week. Persons are the pigeons, that is 29. Days of week are pigeonholes, that is 7 days a week. So what we need to prove that 29 by 7 will be 4.142. So we will be having at least 5 persons have been born on the same day of the week. Show that if any n plus 1 numbers from 1 to 2n are chosen, then 2 of them will have their sum equal to 2n plus 1. If any n plus 1 numbers from 1 to 2n. Okay. A1 is equal to 1 to 2n. A2 is 2 to 2n. Then are chosen, then 2 of them will have their sum equal to 2n plus 1. Now we will have A1 is 1 comma 2n. 1 plus 2n is 1 plus 2n. For 2 comma 2n minus 1, that is 2 plus 2n minus 1, 2 numbers, 1 plus 2n. If you consider adding both of elements, you will get the same 1 plus 2n. For n minus 1, 2 into n minus 1. So we have 1 plus 2n again. And if you consider this, n comma n plus 1, that is also 1 plus 2n. Every number belongs to 1, 2, 3, 4 to 2n. if each of the numbers chosen such that their sum will be equal to 2n plus 1 or more. Now on the site Z, a relation R is defined by ARB if and only if A divides B. Exactly. Verify that R is equivalence relation. What is the meaning of reflexive? 1 1 2 2 like that. So what is given here? A divides B. 1 in the 1 divide ಆಗುತ್ತೆ 2 in the 2 ಆಗುತ್ತೆ 3 in the 3 ಆಗುತ್ತೆ. So it is reflexive, clearly visible for all the A belongs to R or positive integer or negative integer, anything. Check whether it is symmetric or not. Now let us consider 2 divides 4. So which means 4 can be the 4 is something which is there in the tables of 2. A divides B means B is something which is there in the tables of A. Okay, something times of A. Then 2 divides 4. 2 divides 8. Then, but oppositely, if we just write 4 divides 2, 4 can't be 4 cannot divide 2. 2 can divide 4, but 4 can't divide 2. It is not symmetric. For transitive, as I said, 2 comma 4 belong to R, then 4 comma 8 belong to R, then 2 comma 8 also belongs to R, because 2 can, if 2 divides 4, 4 divides 8, then 2 can also divide 8. This way, that is proved already. R is transitive. R is not an equivalence relation because it is not symmetric. Let's consider R belonging to A cross A cross A cross A. That is x1 plus y1 equals to x2 plus y2. 1 1 1 1 is one set, then 2 1 1 2 is one set, again 2 1 2 1 is one set, 3 1 1 2 3 1 3 1 1 1 5 1 1 2 1 2 1 2 2 1, like this and so on. Reflexive. Why is it reflexive? As we know, we have seen already, x plus y equals to x plus y, which can also written as x plus y 3 1 3 1, which why, because it is on set A cross A into A cross A. This is the question for that. Let A equals to 1 2 3 4 5 define relation on R, that is A cross A, by which the x1 y1 related to x2 y2. Here 2 elements are related to another 2 elements. Then verify R is an equivalence relation on A cross A. A cross A is the major relation now. Determine the partition of the A cross A induced by R. Now we are writing R equals to A cross A cross A, x1 plus y1, x2 plus y2. The same thing we have here. Clearly says that x plus y equals to x plus y. X comma y are x comma y. Then x comma y comma x comma y belongs to R. So R is reflexive. Then if x1 comma y1 belongs to R, x2 comma y2, then x1 plus y1 is equal to x2 plus y2. x2 plus y2 is equals to x1 plus y2. x2 comma y2 related to x1 comma y1, that is symmetric. Transitive, if x1 comma y1 related to x2 comma y2, x2 comma y2 related to x3 comma y3, then x1 comma y1 is equal to x2 comma y2. x2 comma y2 is equals to x3 comma y3, then the x1 comma y1, x1 plus y1 is equal to x3 plus y3. x1 comma y1 are x3 comma y3, hence it is transitive. Now to determine the partition induced by R, we have to find the equivalence classes of all the elements xy of A cross A with respect to R. What partition we have to do? Let us take 1 comma 1 now. 1 comma 1 ಅಷ್ಟೇ. 1 comma 2 partition ಬೇಕಂದ್ರೆ 1 comma 2, 2 comma 1, then it is 2 comma 1. Then for 1 comma 3 we have 1 comma 3, 3 comma 1, and 2 comma 2. So we have 3 comma 1. Then the extra things whatever we have, those are the partitions. So for 1 comma 4, how can we partition can be done? For 1 comma 4, 1 comma 4 and 4 comma 1, that is the first partition and the last partition. Then the middle partition is 2 comma 3 and 3 comma 2. That is done. So we have 3 partitions here, 4 comma 1, 2 comma 3, 3 comma 2. And for 1 comma 5, as we know all, 1 comma 5, 5 comma 1, middle partition is there. Since it is a odd number, we have middle number, that is 3. So 3 comma 3 and 2 comma 4 and 4 comma 2. So we have 4 partitions. Then for 2 comma 5, why we directly have taken 2 comma 5? Why? Because here we have already taken the 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, everything, but 2 comma 5 is missing in all the above rows. That's why we are taking 2 comma 5. For 2 comma 5 we have 2 comma 5, 5 comma 2, and in between 3 comma 4 and 4 comma 3. That is done. Now for 3 comma 5, because it is not present in the above partitions, 3 comma 5, 5 comma 3, and there is only one number in between, that is 4. So 4 comma 4, 5 comma 3, 4 comma 4, 4 comma 5, because it is not present in the above rows, 4 comma 5, 5 comma 4, 5 comma 4, and last but not the least 5 comma 5. Hence, to obtain A cross A from above class, partition of A cross A induced by R, that is 1 comma 1 union 1 comma 2 union 1 comma 3 union 1 comma 4 union 1 comma 5 union 2 comma 5 union 3 comma 5 union 4 comma 5 union 5 comma 5. These are all the partitions induced by R. Define partition of a set. Give an example. Let A be A, B, C, D, E. Consider partition A, B, C, D, E of A. Finding the equivalence relation inducing the partition. So it is A could be A, B, A comma B. That is then B. C could be C comma D. That is D. So A makes the partition as AA and AB. BA belongs to R. For B we have the previous thing, that is we have to find the equivalence reducing partition. We have parted it as 2 2 2 2 2. I parted the first two elements first, then the next elements, then we are again joining them together. For A we have AA and BA belongs to R. Then for B we have AB and BB belongs to R. Then for C we have CC and CD, CDC. For C we have CC and DC belongs to R. For D we have CD and DD belongs to R. Then for E we have EE belongs to R. So we have a relation as AA, AB, BA, BB, CC, CDDC, DDEE. The above relation is reflexive, symmetric, as well as transitive. So hence R is an equivalence relation. If A equals to A1 union A2 union A3, where A1 is 1 2 1 3 4 A2, A3 is 5. Define a relation R on A by X R Y if X and Y are in same subset AI for 1 less than or equal to I less than or equal to 3 is R an equivalence relation. Define relation R on X R Y. X and Y are same subset for 1 less than or equal to I and less than or equal to 3. So we are considering it. Now the solution is given by A1 is 1 2 2 3 4 A2 and 5. R is defined by X and Y are the same AI, meaning X comma Y should belongs to R. X and Y both should be in A1, A2, A3. From A1 we will take 1 2. Check 1 1 2 2 1 2 2 1 belongs to R. Yes, it does. So we have taken 1 2. Then from A2 we have taken 2 3. We are having 2 3 4, where we have 2 3 2 4, 2 2 3 3 4 4, and 3 2 3 4. Everything, all the possibilities we have to write. Then from A3 we have 5 5 5. So we have this group as 1 1 comma 2 2 comma 3 3 5 5 and everything. Four, 3 3 4, all. This is equal to R. Clearly R is reflexive, symmetric and transitive. So R is an equivalence relation. Then let A be equal to 1 2 3 4 and R be relation on A defined by X R Y if and only if X is less than Y. X is less than Y. R is in ordered pairs, R matrix, R digraph also we have to write. List all in degrees and out degrees of every vertex. R equals to 1 comma 2 1 comma 3 1 comma 4 2 comma 3 2 comma 4 and 3 comma 4. Here the X is less than Y. Then we have reflexive. It's not reflexive because 1, 1, 2, 2 are not there. For symmetric, if A is less than 2, that is 1 is less than 2, then can 2 be less than 1? No, not at all. It's not possible. So it is not symmetric. Clearly visible that A belongs to A is less than B is less than C, such that A is less than C. R is not equivalence, but R is transitive only. Then for MR graph, we have all the possibilities as well as the graph. There is an edge between 1 to 2, 1 to 3 and 1 to 4. So we have this. We have got upper triangular matrix, that to right upper triangular matrix. Then G of R, graph of R, we have received. I guess you are already familiar with this in degree and out degree writing. Let A is equals to 1, 2, 3, 4, 5, 6 and R be the equivalence relation on A that induces the partition 1, 2, union 3, union 4, 5, 7, union B 6. Get the partition of 4 blocks which they are already given on A that induces the partition 1, 2, union 3 come on. From 1, 2 we will get 1, 1, 1, 2, 2, 1, 2, 2 belongs to R. From 3 we will get 3, 3 only. Then from 4 we will get 4, 5, 4, 4, 4, 7, 5, 4, 5, 7, 5, 5 and 1. Then relation will be all the union of this. Yes, R is an equivalence relation. That's it.
Thank you for watching. Do like, share and subscribe to my channel.